presentation screen?
Yes, Dr.
All right, we will start. Wait, I will record this. Yeah, you guys also can record by yourself. You using the Teams. And good morning to everyone. So today we're going to do our final lecture for this semester for these subjects, operating system. So basically this is a network, the title for this chapter is Network Organization Concepts. Okay, this is the basic networks. This is the basic networks for the operating system. For those from the from the network or computer system department, which is same with my department. This is you will be learn more during your most probably second and third year the network. Most of you, some of you like other departments, maybe this is the only network you can see. But all this is the basic networks in the operating system. Okay. So learning objective is like conflict resolution, like you learn first come first serve. List recently out, list recently in, before this file management, this management, everything. So this is all the conflict resolution you want to solve. So in the network, conflict resolution procedure allow a network to share common transmission hardware and software effectively. So we will learn also about the two most basic network. It's not really network protocol, but this how do you classify a software and hardware systems in or we call that open system interconnection in telecommunication, in computer science, even in electrical engineering. These are the two transport protocol, the basics, which is OSI and TCP/IP. Okay. This is more on the network side, IP address, MAC address and stuff. So how the layers of each one compare. So like a network, basic terminology, network, more than one computer, two computers or more. If you have two computers, you like connect with each other, this is considered you can call it a network, a small network. It's a collection of loosely coupled processors, okay? Processors or machine and stuff. This is from the textbooks. It is interconnected by communication links. You can using cables. Cables can be coaxial cables. Coaxial cables can be twisted pair, copper. Copper is like the old telecommunication line, or I don't know whether you guys have used Streamix before. Streamix, I know you guys familiar with Unify and stuff, but Streamix they use copper, okay? Enhanced copper so that they can get a broadband. Broadband last time Streamix considered broadband, but nowadays Streamix is not really a broadband. Broadband by definitions, it's according. I mean, it will be updated from time to time. Okay, I mean in like this years, I guess, or in the recent years, maybe broadband is more than 100 megabit per second is considered broadband. Other than that, or maybe lower than 10 megabit per second is not considered broadband. So the terms or the definition keeps changing according to the time. So you can use cables, wireless technology like Bluetooth, 4G or LTE, 5G now. Okay, we talk about. I hope that any one of you already vaccine. Okay, so don't trust the conspiracy theory like 5G chips injected into your bodies and stuff. I already vaccine last week. So hopefully everyone can be vaccinated. So this is the way. This is the only way that we can battle the COVID through the herd immunity. Okay. So that wireless technology and also both using the both combination of cables and wire. Of course, for long haul communication or internet, how do you connect to the server in US or in China or anywhere in the world using the optical cable, submarine optical cable? Okay. And the common goal is to provide convenient resource sharing. So you can share anything like from peer to peer to the centralized server, even a blockchain. And then you have a control access based on your level, what you can do. I mean, either you can read, write, or you can read only, or you can read and write. Okay. So this is a control access for the networks based on your user level. And there is also a general network configuration like network operating system, NOS, or distribution operating system, DOS. Like cloud computing, cluster computing, all is a distributed operating system. Network operating system is basically some sort of centralized server, but now all moving to the distributed operating system, or in a hybrid kind of way. You have a central and you of course you also have a distributed. The newest line like blockchain is more to distributed operating system. And they have another terms called a parallel computing and stuff, all under the distributed operating systems. So network operating system is a networking capability added to a single user operating system. Users aware of specific computers and resources in network, where you can see like which machine that involved or coming into your network, and access resources log on to remote host. Okay, and data transfer from remote host. So this is a network operating system. So all modern operating system have this NOS capability. Okay. And how they do interconnect? You have Apple have their own operating system, Linux have own, and Windows and stuff. They use the same protocol to communicate with each other. And then we have a distributed operating system. Users not aware of specific computers and resource in network access remote resources as if local. Okay, it's a good control for distributed computing system, allow unified resource access, meaning that you can also like combine the power of each machine to do a specific task. To view across multiple computer systems, no local dependency for controlling and managing resources, meaning that let's say if you're in Malaysia and you also combine, you have a distributed systems network was from someone in Thailand or maybe US, you can combine all this machine as one single machine. You power up, you can do a specific task, a heavy task. Okay, what we call that is a cooperative management, where you share your resources like processors, hard disk space and others, or maybe RAM. Okay, to speed up or to make your to process your application or specific task in more speedier way. Okay, to speed up your process or specific task, usually a heavy simulation. Okay, or some system that need what we call that, a very complex mathematical formula like statistics and stuff. So distributed computing system comprised of 4 managers. You have a processor managers, you have a device manager, file manager, memory manager, and some of the textbook they put a network manager as well. Okay. So the five-sided pyramid include how the five managers and network system work together for the user interface. Network managers, some use a network manager, but some textbook doesn't use a network manager. So the basic one, you have a processor, device, file, and memory manager. But due to this network manager is like recently added. Some of it doesn't consider network manager as the base or as the basis for that. So what is the basic? What is the advantage of distributed system? So it's easy and reliable resource sharing. You share your computer processor, your power to do a specific task like simulation or counting like protein cell and stuff. A faster computation, of course. You combine 3-4 computers. It's much more better than you use a single computer to do a specific task. Adequate load balancing, meaning the load or the load, or we call that a process, is is evenly distributed among machine that involved in it. A good reliability, of course, you have a speed, and then it's more accurate and stuff. Of course, you also learn about the mutex. We call that before this a mutex. Critical section and stuff. Be careful on that so that it will not return the false value. Okay, it is reliability, but you have to be careful on the mutual exclusion, critical section and stuff. Some of it you have to, some of the specific process you have to do it first without without involvement of any other process, so that the value will not be returned false one, it will be a correct one. And also dependable communication among network users, like if you have a distributed a single point failure, okay, like okay. So the node, and also this one is a client, is also considered a node. Server also is considered a node. If the client host has resources needed by the server host, the roles can be reversed. So basically, the client need something from the server. Okay, he requests to use a service from the server, and if everything's on the node side, everything checks. I mean, this is the legitimate user. This is a registered user and stuff. No other security loophole, and all of its like its operating system is up to date, and everything. So the server will reply, so that will reply either the request is successful or not. If what I mentioned is all checks, the server will allow the node to access the application or services that this server offered. Okay, if the client host has resources needed by the server host, the roles can be reversed. So it also can be reversed. Okay, not the client as a server that not needs specific service for that. Okay, so this is a site is a location. Okay, node, host server, host client. So these are all the basic terminology. I think you understand. I mean, this is pretty much self-explainable. Network topologies. Okay, when you scale network topologies, how are the networks connected? Okay, physically or logically connected sites. You have a star, you have a ring, bus tree, and hybrid. Okay, star connection, ring connection, bus connection tree, and hybrid is a combination of two or more systems. So each topology have the advantage and disadvantage. Okay. We call it a topology trade-off. Need for fast communication among all sites. Okay. Tolerance of failures at the site or communication link. If you have like a round robin, if one of the node fails, it can be a single point failure, meaning that I think it's a round topology. If one communication, one node fails or disconnected, every network will be failed. Okay, there's no way for you to communicate. Cost of long communication lines. Okay, of course you need to like in internet, the fiber optical cable submarine is not really. I mean, the fiber, when everything involve fiber optic is a costly. Okay, difficulty connecting one site to larger number of other sites. All right, so you need to have physical connection. Of course, now like Facebook founder Mark Zuckerberg tried to try to use I think a satellite to give what we call that, a cheap or affordable internet connection for all the users, for all the internet users. He targeting like a third world country or non-developed country, something like that. So 4 basic criteria for you to consider which network topologies you want to use. The first one is the basic cost. Expense required to link various sites in the system, like integration and stuff. Communication cost, bandwidth, time required to send message from one site to another. You know, bandwidth, that's why when you like want to subscribe to internet, you see the bandwidth. The higher the bandwidth, meaning the more expensive your internet connection price will be. The bandwidth is a business. Bandwidth is basically I want to say bandwidth is actually expensive. Okay. Reliability, assurance of site communication of link or site fails. You have a very critical information, custom information, or you are bank or any what call that, like military communication and stuff. They must have a redundancy or backup links. Let's say you use a fiber optical as your main communication line, and let's say the fiber breaks, and then you have a backup link, a satellite backup links. Okay, so whenever the fiber like break or something, it will automatically switch to the backup link, which is a satellite or any other communication, backup communication. Mostly they use satellites, okay, for the backup links, because satellite is much more difficult to break. Okay, and then user environment, critical parameter for successful business in investment. All right. Sorry. Okay. So first we have a star topology. Transmitted data from sender to receiver, passes through central controller. Okay, hub or centralized topology. So one of the advantages of hub or centralized topology. Just imagine like wireless also can be like a star topology. All right, you have a central controller. So this is your access point, and this is your smartphone. This is a laptop. This is a smartphone. Another smartphone. If you have this is typical setup in your home user or your university or stuff. So you have anything, if you want to connect, like user A want to connect to user B, they have to go past the access point. Okay, A connect to access point to will redirect the packets or whatever traffic to user B. This is the central controller. Call that in star central controller. So hub or centralized topology. In wireless also you can have a star. So advantage is permit easy routing, easy to set up, low overhead, low cost, easy access control to network. Okay, everything is controlled by the central controller or access point. So disadvantage requires extremely reliable central site. Let's say this access point fail, there is no way user A, B, C, or D can communicate with each other because everything they depends on the access point. Requires ability to handle all network traffic, no matter how heavy. So access point, of course, in a small home users, it's okay to use a low-end access point, which is low memory, low processing capability. But if you are in the university or larger in enterprise network, you must use a high-end access point. Okay, high-end access point, or maybe a multiple access point. Okay, with a different channels. You know, if you learn about wireless, if you have not necessarily if you have many access point, you can increase the network. Access point depend if you learn about the wireless channel 802.11 A, B, and G. They have 14 channels. If you use the same channels, that channels will be congested. So the planning of wireless network is it's also very important. Okay, network engineer must know that. So this okay. So this is the for star topology. You have here star topology. Hosts are connected to each other through a central controller. Okay, which assume all responsible routing message to the appropriate host. Data flow between the host and the central controller is separated by the dotted lines. Okay, host 1 would want to communicate with host 5. All have to go through the central controller. Host 1 cannot go to host 6 and host 5. No. A star topology, you have to use a central controller. So whenever the central controller fail, all host 1 until host 5 or until host 6 cannot communicate with each other. This is a single point failure. And there is no backup for this. The star topology. But star topology is the easiest, low overhead, the lowest cost of configuration. It is okay for the small home network. All right. Direct host to host or ad hoc cannot. It's not permitted. It's not possible. Although host 1 and host 6 may be just side by side, if the central controller fail, host 1 and host 6 cannot communicate with each other. The link is broken between host 1 and host 6. Of course, if you host 1 and host 6 is like your laptop or your smartphone, of course, if this you need to transfer data and your access point fail, you can turn on your Bluetooth and doing peer-to-peer transaction, something like that. Okay, this is for the star topology. Am I too fast or is it okay? You can understand?
Okay, Doctor.
Okay. Okay, so this is I mean I'm a practicing network engineer last time before I joined academic, so this is okay for me to teach. Sometimes I just like going, if I'm going too fast, just remind me, okay? For those in the computer system department where you are network, you planning to major network, this is your basic. If you cannot understand this, there's gonna be a problem on the later stage. All right. So ring topology, sites connected in a closed loop. A ring topology is also around. Just imagine a ring. Although what I'm drawing here is not really good looking ring. Sites connected in closed loop may connect to other networks, use bridge, same protocol, or using a gateway, different protocols. If it is within the same networks or within the same, what we call that autonomous system, you can use a bridge, okay? Or using a gateway for different protocols outside networks. Data transmitted in packets, okay? I don't know whether you, some okay, data can be sent whether in frames or packets. There are two major ways, frames or packets. Frame usually in level 2 like a MAC address layer, or packets in level 3 using the IP address and stuff. So data transmitted in packets. Source and destination address fields. So it's very important to have the IP address. 192.10 or something like that, okay? Packet pass from node to node, one direction only, one direction. I don't know, no, the one direction used to be, when I was in, there's one band, don't really, I mean, this is a Cheeks band. When I was in doing my PhD in Australia, this band coming to this series, Brisbane, it's like very historical, not sure. I hope I don't know whether this you know this band or not, but that's okay. That's beside the point. So every node must be functional. Bypass fail node needed for proper operation. So every node must be functional. Okay, you have a node here, you have a node here, you have a node and node here. Okay, let's say there is no bridge or you are communicating with each other. If this link fails, will you can say that basically all the networks fails. Okay, this is also a single point failure, unless they are, if they are in half duplex or not half duplex or one-way communication, one direction. Okay, one direction. If you have a full duplex or two-way communication, it will not be a problem. If you are one direction communication, any failure in the node will also fail the whole network. Okay, bypass fail node needed for proper operation. Of course, if like one node fail, you have to like really troubleshoot this or use other nodes that wants to join the network, a new node or something like that. So ring topology, hosts are connected to each other in a circular fashion with data flow in one direction only, shown here as dotted lines. Okay, one directions. The network can be connected to other networks via a bridge or gateway. Okay, a bridge or gateway. This is bridge for the same network, same protocols. Gateway for different networks or different protocols. Okay, you can configure this if you go into your access point firmware. You can access whether a bridge or gateway. Okay. So this is the, let's say the host 3 fail, basically all the network will fail as well because it's a one direction. Double loop computer network using a ring topology, packets of data flow in both directions. So if this happens, let's say like host 5 fails. Actually, even though if the host 5 fails, this is also considered a single point failure, but it is better because it's much more faster because you have either this side or this side, you can communicate. Okay, let's say host 5 cannot go to host 5 want to communicate with host 6. He cannot go through the host 5 because this direction failed, but he can go through the host 6. So it's not a single point failure, but you have to go through many loops instead of only 2 hops. You only have to go to 1, 2, 3, 4, 5 hops instead of 2 hops. Okay, hops. In communication, every node, if you jump from one node to one node, we call hops. Okay, host 4 to host 6, let's say host 5 fail, you have 1, 2, 3, 4, 5 hops instead of 2 hops, 1 and 2 if going by this direction. So this is the improvement to the ring topology, double loop computer or full duplex communication, 2 ways communication, 2 ways, two directions or something like that. So ring, so this is like a bridge you want to, let's say this is the system 1, system 2 and system 3. let's say host 6 want to communicate with host 9, you will go through bridge number. Okay, this is bridge A, bridge B, bridge A, and bridge B. If host 6 want to communicate with host 9, it will have to go to the bridge A. Okay, we'll have to go through bridge A and then going to host 8 and host 9, from host 6 to host 8. So this is where you communicate. All right, and this is one direction. Multiple rings bridge together. 3 rings connected to each other by 2 bridges. This version of ring to allow several networks with the same protocol to be linked together. Okay. If any of the bridge fail, there's no way you can communicate with the network number. Let's say bridge A failed. There is no way you can communicate with network number 3. 1 and 2 cannot connect to number 3. But let's say host 10 fail, you still can, host 6 can still go to host 9, right? But host 9 cannot reply to host 6. Still is a communication failure, but it is better than the single point failure. Now we go to the bus. Sites connect to a single communication line, okay? Message circulate is both direction. Just imagine you have a bus, a real bus in a road, in our normal road, okay? So bus can go both directions, okay? One side sends message at times successfully, and bus also need a control mechanism to prevent collision. Collision is just like accident, okay? You cannot okay, maybe this bus is what we call that, although circulate in both direction, but only one vehicle, only one packet. Okay, so this is the like communication line. It can of course it can go both ways, but at one time only one way can be used. I mean only one packet can be used in either way. Let's say the packet want to say from B to A, from B to A. So at this time only packet that this time from B to A can be used, not A to B. Until this one clear, this side or from A to B cannot be used. Okay, cannot be used from A to B. If B to A is in active session, B to A in active session, so A to B cannot be used. If any packet want to send from A to B, you cannot use this line until the packet this time from B to A already finish or terminate or complete. Okay, although it's in both direction, but only one direction can be used at one time. So you need a control mechanism to prevent collision. Let's say you want to send a packet from B to A, and there is also another guys want to send packet from A to B. So if like this packet goes in the same communication line, they will have a collision. Imagine this is a small, very small road, and there are bus coming in both directions. Of course, there will be accidents or collisions. I hope that you understand this bus topology. This system usually a half duplex. Of course, nowadays communication all a full duplex, meaning that you have like a communication line. There are two. One can go one can go this way, one can go this way. Okay. It still have collision, but the collision has been minimized. This is a full duplex. Full duplex communication. This is a half duplex communications. At one time, only one way or one way packet communication can be used, not both ways. So just don't be confused with the both direction. Link can be used in both directions, but at one time, no two links, two different directions can be used at one time or simultaneously. Yeah, word simultaneously. So data passes directly from one device to another. Data may be routed to endpoint controller at end of the line. Okay, data may be routed to endpoint controller at the end of the line, so it can be routed to the point controller. Okay. So this is the bus topology. Hosts are connected to one another in linear fashion. Data flows in both directions from host to host and is turned around when it reaches an endpoint controller. Okay. And is turned around when it reaches an endpoint controller. Let's say host 1 want to communicate with host 4. So it will first check whether the line, whether the bus line or the wired. Consider this the like line or the wired in your circuit. Host 1 will check whether the line is idle or not ready. So if there is no connection, the host 1 will send the packet to host 4. Okay. And at this time, endpoint controller we consider this line is busy because host 1 is sending a packet into host 4. And then after host 4 finish receiving the packets, it will route to the endpoint controller, and the endpoint controller will send a signal something like, okay, the packets already, the packet transmission already completed. So the bus line or the circuit now is idle. So any host can send to any host at this time, at this moment. And of course, you have also a tree topology, collection of buses connected by branching cables. Just imagine a tree. There is no closed loop. Designers create network using bridges. So message can come from any side, received by all other sides until reaching endpoint. Until reaching endpoint. Reaches endpoint controller without acceptance. Host absorbs message. So one of the advantages is message traffic still flows even if single node fails. Okay. Advantage is single node. Just imagine a tree. Branches of tree. Okay. So this is a tree topology. Data flows up and down the branches of the trees and is absorbed by controller at the endpoint. Gateways help minimize differences between the protocol used on one part of the network and a different protocol used the branch with the host 7. Okay. So you have here a tree topology. If any of the node fails, it can still connect it with each other. Okay, this is a tree. So hybrid, basically the name itself suggests a combination of more than one systems, either tree or ring. Either star or ring, star or tree, or something like that. So hybrid also can, like this is the example of star and bus topologies. So network types according to physical distance covered. Okay, the physical distance covered, whether it's big, small, with the local area network. Local area network is within your building, your department or something. We call it a local area network. Metropolitan area network maybe between like in KL, like this building within KL, maybe called a metropolitan area networks. Connected between city, okay, inter-city connection. LAN is more inter building. This is more to inter-city, and wide area connection is like basically internet, okay, like interstate or something like that. Wide area networks. So you have these three topology that you have these network types, all based on the size and the distance. LAN cover a small distance. This is a medium distance or medium size. And internet basically a long distance or size, larger size. So local network, so single office building and stuff. I think you know local network. Whenever if like your lab computer, your computer labs. I'm not sure you are not. Have you like you guys are first year or second year? I think you are second year. Have you guys like have you guys like checked in into the campus yet? Hello?
Just not just.
Yes. Okay.
Yes, yes.
But I mean, if you are checked into the campus yet, so you have some like you have experienced some of your student life. Hopefully, I mean, if you are not even checking the campus where you are registered students, I hope that one day you can check in into the campus. We together we pray that COVID-19 will be over. All right. So local area network is a single office building campus like computer labs and stuff. Single organization owns or operates. Okay, if it's like faculty networks like computer science network is considered a LAN local area network. Communicate through common communication lines. Okay, if you see like 192 or 192.168 IP or 10.x.x.x, this is mostly IP address for local area networks. Okay, local area networks. Not sure whether you're familiar with the public and private IP address, but those in the computer system networks, you will learn about this in a network subject. So if you have 192.168, if your IP address start with 192.168 or 10.x something, or in IPv6, can't remember 6 or something in hexa. IPv6 in hexadecimal, okay, hexadecimal. This is still in decimal. But IPv6 address format is in a hexadecimal. It's communicated through common communication line. Okay, communication is not limited to local area only. It can be a component of larger communication networks. Maybe like computer science is near to the computer science. I just want to, larger communication like computer science near to the 8 college or 10 college. So this both of like computer science 8 and 10 college can combine. Their network can combine, and it also can be called a local area network. Okay, FSKTM. 10 college or 8 college. So this one can be also combined to become local area network. So easy access to outside through bridge or gateway. So internally you are considered as a private network internally. So your IP 192.168 and 10. But if you go through bridge or gateway, you have to use a public IP address to communicate with others. Or you want to communicate through internet, you must have a public IP if you want to go even to others. The FSKM 10 college and 8 college. If you want to go through internet, you must have this is a border gateway router or something, or bridge. So bridge connect two or more geographically distant LANs. Distant LANs like same protocols bridge connecting to two LANs using Ethernet. So like FSKTM, I use example like FSKTM will bridge to like 8 college. Okay, so you use a bridge. Connects two or more geographic distance LAN. Gateway connects two or more LANs or systems. Let's say if you want to go to two or more LANs or system. It can also be a bridge, it also can be a gateway. It's interchangeable. But bridge for the like same networks, smaller networks. Gateway is if you like totally different systems, totally different departments and stuff for the gateways. So different protocols translate one network protocol into another. Resolve hardware and software incompatibilities. Totally different system. Okay. SNA, single network access server, if I'm gateway connecting microcomputer network to mainframe host. Okay. Bridge and gateway, sometimes they are used interchangeably, but you know bridge as connecting two systems, two similar systems, two same protocols. But gateway like two totally different system or totally different protocols. You use a gateway. Local area networks 100 megabit per second to more than 40 gigabit per second. This is gigabit Ethernet or something, gigabit Ethernet. 100 megabit per second is for normal coaxial cable or twisted pair, copper. It have a close physical proximity, very high speed transmission, okay? Star, ring, bus tree, and hybrid. Normally use this network topology. Transmission medium varies, okay? Can be wireless, can be optical, it can be coaxial or copper. Okay, factors determining transmission medium like cost, data rate, reliability, number of devices supported, distance between units and stuff. Okay, of course, if you are copper, if you use a copper, normal copper, it can by ITU rules or telecommunication rules, it can only cover up to 100 meters. Okay, up to 100 meters. More than that, you have to use coaxial or fiber optical cable. Okay. Then we go to metropolitan area network. Metropolitan area network is basically a larger LAN. A larger, LAN, you can imagine a local area network with bigger capacity. Several blocks of building to entire city, not exceeding 100 kilometers circumference, okay? Or radius. If 100 kilometers circumference, the radius is 50 km, okay? 50 km. Owned and operated by a single organization. Used by many individuals and organizations. May be owned and operated as public utilities, means for internet making several LANs. Okay, it's a high-speed network often configured as a logical ring. Logical, it's still a ring topology, but it's a logical one. Okay, owned and operated by a single organization, maybe is ISP, Internet Service Provider. But ISP can offer service to by many individuals and organizations, okay? Owned and operated, but used by many individuals and organizations. So this is more a company or client. This is more on the ISP level, like TM, Maxis, DG, or others. Time, okay? Means for internet working several LANs. So if you combine LANs, if there are too many LANs, you can also call it a metropolitan area network. High-speed network often configured as a logical ring, not a normal ring topology, but as a logical enhance of ring network. Now you have wide area network, or basically this is internet. If you have your wireless access point with you, you can see like. Of course, if you have a wireless access point, you can see like 4 ports, 4 LAN ports. And then you have another looks like LAN ports, but at the interface it put 1. So 1 is for the internet connection to the outside world. So wireless network interconnects. Okay, let's say you have a wireless access point at wireless. This is your wireless access point on your back of your wireless access point, and you have let's say you have 4 ports LAN. This is LAN networks, and then it's separated by line or something, and you have another looks like a LAN port, but this interface called 1. Okay, 1. 1. Okay, so this for the internet. So this LAN, maybe you have your, this is your PC, this is your network printer, or this is your maybe server, your CCTV or something. So this you can put on LAN. But once you want to connect to your modem, your unified modem, or you use a unified modem, or you want, if you have basically a modem or any internet port, your Ethernet port from the building, you want to connect outside, you have to use 1. So this is the interface of your access point. I hope you understand this one. Wide area network operated as a part of public utility. Use common carriers communication lines, telephone companies. Use broad range of communication media like satellite or microwaves. Okay, you want to connect to internet, there are like fiber optical, you have satellite, you have a microwave. if you like drive around city, you can see a communication tower, or just look at the high-rise building. At the top of the building, you can see a lot of antennas are being installed there. It can be a satellite, a microwave. It can that mostly if you see the antenna being installed in a communication tower or in a high-rise building. When you drive around, when you pass through the high-rise building, just see just look at the top of the building. Okay, just look at the top of the building. Or if you live in condominium or apartment, if you have a chance, go to the top, go to the rooftop, or you can view the rooftop. You can see a lot of antennas are being installed. It can be a microwave, or it can be a normal LTE for 4G communications antenna. Satellite is much more bigger. One of the satellite satellite dish, one of course a smaller satellite dish is Astro Communications. If you have Astro, nowadays not many people using Astro because you have like Netflix and stuff, so you don't use Astro. But Astro is a smaller satellite communication, okay, smaller. But actual satellite dish for internet is actually bigger. If you have a chance to go, I think Petronas, some of the big Petronas station, they have a satellite dish, okay, satellite dish for their. It is used to check the fuel level, okay, the fuel level. Let's say the fuel level is low, so the fuel tank will come in and fill inside that Petronas station. So satellite is like bigger, much more difficult to control or to configure. So this is just a broad range of communication media. WANs generally slower than LANs. Okay, if you have WANs, internet generally is slower than a local area network. ARPANET, the first one, you have internet most widely recognized one. Internet. So when I say internet, everyone knows is a wide area networks. Can be within the country or inter-country or something like that, globally. Now we have a wireless local area network. So it's basically wireless local area is a LAN, local area network, but use wireless transmission medium. So located within range of network. Your normal Wi-Fi, if without blocking, without wall or something, in ideal form, it can the range is up to 250 meters. Okay, 250 meters. Of course, you can use a booster or a repeater or something to extend the range. But in a normal circumstance, in a normal Wi-Fi without blocking, without wall or without building, it can go up to 250 meters. And the security vulnerabilities, of course, the wireless is much more exposed to the hackers and stuff. So they have a security vulnerabilities that the wired don't have. Because it's an open architecture, difficult keeping intruders out. So intruders, basically, if intruders is within the wireless network, it can easily hack as long as you can get the web key or something like password or something, or maybe he tried to do. That's why you are advised to use a web key or password, a longer password, so that it difficult to break. Don't use like ABC 1 2 3 4 or something, or just 1 2 3 4. Don't use a password like that. So these are IEEE standard A, B, G, and N. So you have a 54 to 600 megabit per second. 300 range indoors, 300 feet. Oh yeah, 802 can go to 300 feet. 5 gigahertz. This is the license bands. Okay, not everyone can use 5 gigahertz. You have to apply for MCMC. 2.4 gigahertz is a free band. Anyone can use 2.4 gigahertz. For 5 gigahertz is a licensed band. Meaning that if you want to use a UISP, you want to use 5 gigahertz, you have to ask from the MCMC. It's a licensed band. Unlicensed band is to 2.4. Not sure whether 5 gigahertz they have a licensed band or not. But if a licensed band, meaning that it's much more faster, of course, much more expensive. And then you have a WiMAX. People don't use WiMAX anymore because WiMAX has been successfully phased out by 4G or LTE. WiMAX standard is 2.16, high bandwidth and long distance. So in a wireless LAN, wireless mode connect cable LAN via access point if they are located within the range of device sending the signal. Okay. Wireless enabled nodes connect to cable LAN via access points if they are located within the range of device sending the signal. So what is the issue in the networks? How do sites use addresses to locate other sites? How are messages routed and how are they sent? So this is the intelligence of router. How the site use address like 192.10 or something, the IP address? How do process communicate with each other? Processors communicate with how do like different system, different software communicate with each other? How? Like how do the Unix system communicate with the Windows system, or Windows want to communicate with the Apple systems? How conflicting demands for resources are resolved? So this is what we call a protocol. Protocols mean the address that you use. Address that you use, okay? What's the time now? Do you think you need 5-minute breaks? Or you just want to continue?
5 minutes.
Okay, sure. So we have a 5-minute break. So now 12:03. So 12:10 we will I will continue my lecture. Okay?
Okay.
Okay, shall we continue? You guys still with me?
Yes.
Okay, right. So addressing conventions, so addressing protocols, the networks need to uniquely identify users. So you must have your unique identifiers, just like your IC numbers, okay? Or your IC numbers or your name is uniquely to you, okay? There is no like there are like no two IC's number or your passport number, that two same passport numbers users. So in this, like in network, is identified by either IP address or the MAC address. Okay, it also closely related to site network topology and geographic location. Okay, like let's say if you are from the TM telecom networks, or maybe you are from Maxis network, they have a specific address IP address range. Okay, or you are from KL Kuala Lumpur, they have a specific IP address range. From Selangor or from Pahang, they have a specific IP address range, or even from Malaysia, specific address range, a bigger specific address range. Okay, closely related to site network topology and geographic location. So this is okay. Whenever I see, or if like let's say the IP address is 312.56. Sorry, no, cannot go 56. Only 255. Oh, sorry, there's not even 312. Okay? The IP address only 255 maximum. Let's say 231.18. Whenever is a 231.18.x.x. Whenever 231.18, okay, this IP address is definitely from KL or definitely from Maxis. Okay, 231.18, something like that. Addressing protocols. Distinction between local and a global name. Local name with its own system. Global name outside its own system. We call it autonomous system. Must follow standard name conventions, like lang or formats. Okay. And of course, you have this addressing protocol. So internet address is like someone like icarus.sp.edu. Use domain name service DNS protocol. DNS protocol meaning that you convert the IP, you convert the name, you convert the website, or you convert the name server icarus.lis.pit.edu into the IP address. Okay. Domain names read left to right. Logical users to host machine. Host machine to network machine. Network machine to cluster to network. Okay. Periods separate components. Okay. Separate components. Okay, like if you take example from this one, sorry. So someone is a logical user. Someone is a logical. Okay, Icarus is the host for the user called someone. This one is a host for user called someone. Or maybe like let's say your name, like mine is Saidal, UM.u. Saidal is my logical name. UM is my host. And sorry. PIT is for the cluster for like library information system and stuff, and then EDU is network for university or educational website. Okay, domain names are read left from right. Logical users to host machine to net machine to cluster, and cluster to networks. Period separate the components www.um.edu.my. Okay, something like that. Logical users, host machine, net machine, cluster to network. Network Malaysia, education network is a UM network, and so periods. These periods separate the components. Same like 192.168.10.3. So this is all the it reads from left to right. Okay. Addressing conventions. Router. So router is from the word route, or some call it route or route. Call it router. Is an intelligent device that route the packets. Okay, intelligently route your packets from source to destination. Okay, internet networking device, primarily a software driven. It directs traffic between two different types of LANs, between two network segments, different protocol addresses. Okay, two different types of LANs or between two network segments. Okay, let's say you have this is the HR department. Okay, in the LAN case, HR department, you want to connect with the engineering department. So you put a router here so that it can, if like this host wants to communicate with this host, so it will intelligently route the packets from source to the destination. Or between two network segments, different protocol address, okay, or any internet address, okay, from KL to Pahang or something like that. Is a network layer operation, network layer. Role changes, network design changes, okay. If the role changes, the network design also must be changed. It connects sites to other sites and internet. Okay, this is a router to route packets, as the name itself, to route packets. So router function is for securing informations generated in predefined areas. Choosing securing information generated in predefined areas. Choosing fastest route, okay, intelligently choose the fastest route from source to destination. Providing redundant network connection, like one route fail or have a link breakage, you can easily reroute to other backup connections. So routing protocol consideration like addressing, address resolution, message format, and error reporting, all this in the routing protocol. And address resolution maps hardware address. You have hardware address is a MAC address on your machine. Okay, MAC address. They have MAC address and they also have a internet address. So message formats allow performance of protocol functions, finding new network nodes, determine whether they work, reporting error conditions, exchanging routing information with other router or maybe switch, and establishing a connection. So you have this is the most basic routing protocol. The first is routing information protocol called RIP, or Open Shortest Path First, or OSPF. So what is RIP? RIP. Sorry, you cannot say. RIP is something when you say to someone like someone already like passed away. So RIP. Sorry, not RIP. RIP. Pass a selection based on node and hope number between source and destination. Okay, let's say this is the source. Okay, this is the source. This is the source. This is the node, and this is the destination. Okay, let's say this. Okay, this call a different colors here. Maybe green one. So green one. Blue one. And purple one. Okay, based from this one is okay. Path selected based on the node and hop number between source and destination. Path with a smaller number of hops are chosen. Hops. So let's say, okay, this is route 1, route 2, and route 3. Route 1 have 1, 2, 3, 4 hops. So route 1 have 4 hops. Route 2 have 1, 2, 3, 4, 5. Route 2 have 5 hops. And route 3, 1, 2, 3. So route 3 have 3 hops. So based on the routing strategies or based on the RIP protocols, which one he will be selected? Node and hop number. So packet with the smallest number of hops are chosen. Hops are chosen. So it will definitely select the route 3 because route 3 have only 3 hops. This is the shortest hops number. Okay, advantage is easy to implement. This one is very easy. The algorithm is easy. A few line of codes can easily implement this RIP. But disadvantage, no constraint on bandwidth, data priority, or network type. Update and ratio routing table. Okay. First, no constraint of bandwidth, data priority, network type. Let's say this route number 3 have a shortest route, only 3 hops. But let's say hops number 1 and 2 are busy. Okay. Hops number 1 and 2 are busy, or maybe 1 and 2 only use copper. Okay, let's say route 2 even they have 5 hops, but they use a fiber and it's idle. But using the RIP protocol, it will still selected route number 3 because route number 3 have only 3 hops. It doesn't consider any bandwidth, data priority, or network type. Let's say you are using a voice over IP or using a voice conference or video conference. Of course you must have the fastest route in terms of the bandwidth, which is fiber. But since this copper line they use only 3 hops, the RIP protocol will still select route number 3 for its routing transmission, packets transmission. Route number 3. Although route number 3 is slow using copper and route number 2 using fiber, it will still select route number 3. Update and reissue routing tables, changes or not. So, okay, one of the problem in RIP is every 15 seconds, the router will update its neighbors, okay? Like router number 1, every 15 seconds will update its neighbors. Router number 2, router number 2 also, of course, will also wait 15 seconds. Router number 3 and 15 seconds update enabled. So with this updating information, let's say you have a 30 hops from source to destination, you have 30 hops. 30 or 50, 30 hops or something. It will take about, 15 hops. It will take about around 7 minutes for source to destination to update, which this one will, of course, waste some bandwidth, because if you want to update, you have to send a packet, and then furthermore you have to wait another 15 minutes. And each router every 15 minutes, either the network changes or not, regardless whether the network changes or not, like not leaving or not coming in, it will still use 15 seconds, not 15 minutes, 15 seconds to update. So RIP, each router involved in RIP will use will update its route information every 15 seconds. So this will waste bandwidth. In such not a dynamic network like a static network or wired network, which is there is no like often link breakage happens, you don't need a 15 seconds every router to update 15 seconds. Maybe you need maybe you have a longer time, or only updates when there is a connection or link breakage. So tables also propagate router to router. So router 1, when it updates, router 2 have to update its routing table, and so on. And the source nodes also have to update its routing table. And router 2, when it's update, the router 1 have to change its routing table. Router D also have to change its routing table, and so on. So of course, this will be propagate and will become difficult to converge or to match or to create the network will not be stable enough with bandwidth. And then when they see this the weakness in the RIP, they create a open shortest path first. So network state determined first. So like for the open shortest path, each node have each node like this one, node A, node B, node C, D, E, F, and G, H. So each node have a route to any of other nodes in the network. Like node H, when they want to go to C, they can go to G, B, C, or sorry, this is A. G, B, this is B, I guess. So sorry, this is D. So A, B, C. So if H want to go to C, they have to go to D, A, and C, and so on. So each route knows which path you want to go. Like node H want to go to node C, they have this path. Each route have a routing table for each other node that participate in the networks. So it's a redundancy. Update message sends when changes in routing environment occur. So let's say route D is no more. Route D has, node D has been turned off. So when this happens, only the update message, as opposed to RIP or SPF, only send update message when there is a changes in routing environment. Let's say node D is switch off or link breakage. So all other nodes will send updates instead of interval of 15 seconds like RIP. Okay. It reduces the number of messages in network, more reliable, and reduce message size, not sending entire table, okay, in case of the RIP. One of the disadvantages of SPF is increased memory usage, because you have to maintain all the path from all the path from all other nodes, from all the nodes inside the networks. So bandwidth saving has been offset by higher CPU usage, because this is more intelligent, so it's more processing, so it involves CPU usage. It is offset. Bandwidth savings from RIP is offset by the CPU usage, and it uses shortest path calculation from Dijkstra algorithm. Okay, Dijkstra algorithm use it's not really a this algorithm is used in like it's the basic of the shortest path calculations. If you're using Waze or you're using Google Maps, all are based on the Dijkstra algorithm. Of course, they have enhanced and improved Dijkstra algorithm, but Dijkstra algorithm is the basic for all shortest path calculation. Basic. And then you have a connection models. Moving data from one point to another, minimizing transmission cost, providing a full connectivity. So these are connection models objective. And you have a circuit switching, dedicated communication path established between two hosts before transmission begins. Example is like old telephone systems. You have to establish two hosts before you can use the network. When you have a two hosts already connected, then you can use a telephone. So this is the circuit switching. One of the disadvantages is delay before signal transfer begin, because you must have a dedicated, or the connection must be established between source and destination. It will have a delay before the signal transfer begins. This is circuit switching. So packet switching is store and forward technique. Before sending message, they divide it into, so you have a big packets here, you chunk into smaller packet. You have a big data, and you chunk into a smaller packets. Four packets. Let's say this data have 4 packets. Divided into multiple equal size units or packets. At destination, so okay, this one data you chunk, so packet 1, packet 2, packet 3, packet 4, your connection, and then this is from the source, and when you apply from a destination, all this will be reassembled at the destination. Reassemble at destination. Okay, divided into multiple equal size units. At destination, packet reassemble into original long format. So the packet will become according to the number 1, 2, 3, 4. Data has been retrieved. Header contains pertinent packet information. Okay, you have, of course, you have a header. Header like address, which address you want to send, some kind of information about these data packets. So the advantage is more flexible or reliable, greater line efficiency, much more faster, user allocates message priority. So this is a packet switching networks. It does not require a dedicated connection first. You can just straight away send. It sends packet using a 3-step process. Divide into data into address packet. So this data, usually data is a long one, and it breaks into 3 packets. It sends each packet towards its destination. So packet 1, 2, and 3 not necessarily will use the same route. Let's say packet 2 using this route and to this packet 3 and 1 using this route. So it's not necessarily using the same route to send all the packets. And at the destination, it will assemble back 1, 2, 3. So it becomes the original data back. Okay. So this advantage, this is the difference between the circuit and the packet switching. Transmit in real time, transmit in batches, prefer in low volume networks, high volume networks, high line efficiency, reduced line efficiency. So this is a telephone network, okay? Dedicated single transmission, shared by many transmission, preferred for voice communication. Okay, not good for voice communication because voice is voice or video according to the packet. It's according to the order. This one, if your packet switching is not according to the order, maybe packet number 3 is packet number 3 arrive first before packet number 1, so it will not be in order. So it's not really good for voice communication. Of course, they also have a voice over IP or quality of services. Yeah, when you use like that's why when you use a WhatsApp call and a normal GSM mobile communication, normal call, we call that, you can see the difference, the quality wise. Of course, the normal call will be better than the WhatsApp call, right? Of course, from time to time, they improve and improve. Circuit switching is easily overloaded, and packet switching is accommodated varying priority among packets. The priority packets like voice, like video or something like that will be priority first, will be sent first. And then you have a datagrams, packet destination sequence number added to the information. Uniquely identify message to owning a packet, okay? When you send a lot of packets, there must be a mechanism to identify which packets belong to which packets, okay? Each packet handled independently, route selected as each packet accepted, okay? At destination, all packets same message will reassemble. A packet that belongs to the same group will be reassembled according to that groups, okay? There's a mechanism. That's why you must have a mechanism called datagrams to identify each packet. And advantage, diminish congestion and provides reliability. So congestion can be reduced, okay? And it also provide reliability to the transmission. So message not delivered until all packets accounted for. Receiving no request, retransmission, okay? If there is a loss or damaged packet, receiving note only, okay, instead of 4 packets, only receive 3 packets. So receiving note will request a retransmission for that loss or damaged packets, okay? So again, this is the advantage of the datagrams. Alternate path setup upon node failure. So you have a redundancy. And you have a virtual circuits complete path sender to receiver established before transmission starts. Okay, same. This is more like on the circuit switching. All message packet use same route, several virtual circuits to any other node. So advantage is the routing decision made once, speed up transmission. Okay, this is like a circuit switching as well. Okay, disadvantage, all virtual circuits fails upon one failure. If there is one failure, one node failure, it will be a single point failure. No communication or transmission can be made. Difficult to resolve congestion in heavy traffic. So of course you have a conflict resolution as well. Phase equal and fan error access, okay, whether who's going to use this line or not. You have a round robin, reservation, and contention. Round robin, you serve the user for specific time. Regardless whether they finish or not, you will move to the second user at specific time and so on. And those previously you serve if it's not finished or completed yet, you will serve in the next round. Okay. And then medium access control protocols, carrier sense multiple access, CSMA, when you want to detect a carrier sense multiple access, meaning that if you in the bus in a half duplex system, you want to see whether the network idle is not, you use a CSMA. And you can also a token passing, node that have tokens can send, node that who doesn't have a token cannot send. And you have a distributed queue and a dual bus. So round robin, okay, they have 4 users. You have 4 tasks. Task 1, task 2, task 3, task 4. Task 1 takes 3 minutes. Task 1, 3 minutes. Task 2, 2 minutes. Sorry. Task 2, 2 minutes. Task 3, 2 minutes. And task 4 is 4 minutes. Okay, let's say it's a round robin. Each time you pass the task, you're only given like 2 minutes. Okay, let's say task 1 you took 3 minutes, but when you are in task 1, after 2 minutes, you will go into task 2. So task 1 will left 1 minute. So task 2 you have 2 minutes, and then you finish that. Move to task 3. Task 3 2 minutes. Finish that. Finish. Task 4 you have 2 minutes. You have 4 minutes. You need 4 minutes to finish that. After 2 minutes, you will go back to task 1, and after 2 minutes, you will go back to task 4, and you finish the cycle. If many nodes transmitting over long, not given certain time to complete transmission. If many nodes transmitting over long time periods, substantial overhead. If few nodes transmitting over long time periods. If nodes transmitting over long time periods. So many nodes is okay. If like a few nodes, it will be some item. So it is good for if lengthy and continuous traffic, access time or medium divided into slots or not reserved future times slots. So this round robin. So good configuration, several terminals connected to host through a single input output port. Okay. Okay. This is for the round robin. For contention, no attempt to determine transmission turn. Nodes compete for medium access. Okay, this for contention. Okay, nodes compete for medium. It doesn't have a priority or who's supposed to use first and stuff. You have to compete for the medium. Advantage and disadvantage is easy implementation. Works well under light to moderate traffic. Better for short and intermittent traffic. But if it's a heavy loads, heavy traffic, congested, its performance will break down. So we look at the carrier sense multiple access. So you have a computer here, and then you have a A, B, C, and D. Is it okay? Okay, this is a Ethernet, LAN. Carrier sense, not listen to test connection medium before transmission. Okay, let's say A wants to send to D. So let's say at the moment B is sending traffic to C, C is transmitting traffic to D. So carrier sense multiple access will listen to the medium. Okay, now at the moment B is sending to C is sending to D, and so on. Not listen to test communication medium before transmitting message. Prevent collision with node current, because if if A want to send to D at the same time B is sending to C and C is sending to D, the probability of having collision is high. So this is what we call carrier sense multiple access. It will sense the network first. It will sense the system whether they have a transmission or not. So multiple access, several nodes connected to same communication line as peers, same level and equal privilege. So A, B, C, and D have equal time, equal access to the communication line. So what is this disadvantage? Okay, the advantage is you want to avoid collision. So collision, two or more nodes transmit at the same instant. Let's say, okay, this is node A, node B, node C, and node D. A, B, C, and D. Let's say, okay, A wants to send to D and D wants to send to B. And at pretty much at the same time, when they use a CSMA, they sense this line is idle, but at the same time they want to transmit. When A wants to transmit to D, at the same time D wants to transmit to B, they will become a collision. Okay. When two or more nodes transmit at the same time, probability of collision increases as node gets further apart. Maybe they have some connection E, F, G, which is further apart. It's not suitable for large or complex networks with less appealing access protocols. So the solution is collision detection. So let's say there is a collision. Sorry, this is A, B, this is C, and this is D. Okay. Let's say there is a collision. A wants to send to D, D wants to send to B. So let's say these collisions happen here. So this is where collision happen. So collision detection, CD part is a collision detection. When collision detection happens, it will retransmit, but it will wait a random time. We wait some random time before it can complete, before it continue to transmit. So A and D, now there's a collision. A will wait like, let's say A will wait like 15 seconds and D will wait like 10 seconds, a random time. After 15 seconds, after 10 seconds, D will transmit first and hopefully finish before A complete the transmission. Okay, so they have this reduced wasted transmission capacity, prevents multiple nodes from colliding. Collisions not completely eliminated in the CSMA-CD, but CSMA-CD can reduce down the collision probability. No guarantee data will reach destination, of course, ensures error-free data delivery. Used in half-duplex communications. So there is like a new improvement like CSMA-CA, collision avoidance. This totally like avoid the collision. This is collision detection. This is collision avoidance. So used in half-duplex communication. Last time half duplex, but now in the modern communication use a full duplex. So the CSMA-CD is not really, it's still a good protocol, but it's not really widely used in the full duplex communication. Token passing, special electronic message token, generate and pass node to node. Only node with token allowed to transmit, then passes token. So whenever the node have a token, it allowed to transmit. If node doesn't have a token, it cannot like send the packets or whatsoever. It's a fast access and collision is almost non-existent, and typical topology is on bus or ring. So token pass to node in turn. So this node not already complete task, So it will pass the token to another node. So data attached and sent to destination. Token pass to node in turn, and then data is attached, and the node will process the data transmission. On the receiving node, copies the data as acknowledgement, returns packet to the sending node. So they must have some mechanism to acknowledge back the sending node. Sending node passes token to next node in sequence. So initial order or initial node order determination, cooperative decentralized algorithm, and then determined by priority based on a node activity. So they have a priority base like voice or video communication. They always prioritize that, or very critical information or data, they will prioritize that first. Okay. Token bus have a high overhead at each node than SMA CD, and nodes have long waits before receiving tokens. Node can be wait forever to have a token. So starvation can happen. And you have a token ring. Token move between nodes in turn, one direction only. So the token is in the ring format. To send message, node must wait for free token. If the node doesn't have token, it cannot send the message. Receiving nodes copies packet message, sets copy bit indicating successful receipt. And you have a distributed queue dual bus. It's a dual bus configuration or more full duplex. Each bus transport data one direction only. Steady stream of fixed size slots. So instead of this one single communication one direction, you have a two direction. One goes this way and one goes this way. Slots generated at end of each bus. Mark as free and send downstream. Marks busy and return to nodes that are ready to transmit. Okay, when the marks are free and it will send downstreams. When this operation has begun, the bus system will mark as busy and return to nodes that are ready to transmit data. And return by nodes ready to transmit. Nodes read and copy data from slots. Okay, they have a slots or another node servers. It's continue to travel towards end of bus or dissipate or terminated. So you have here bus 1 generated slots here, slots flow bus 1 from this side, this way, and bus 2 generates slots here, and they have a slot bus 2 slot is from in these directions. Free slots are generated at one end of each bus and flow in only one direction. If like free slots are generated, so any of the nodes can use that free slot. And when any of the nodes use that free slot, it will mark as a busy. So this is the advantage of DQDB. Negligible delays under light loads, predictable queuing under heavy loads. Okay. Suitable for more metropolitan area networks managing large file transfers and satisfy interactive users' need. So this is a transport protocol. As a transport, mean the way you transport the packets, the way you bring the packets, transmit. So since 1980s, network usage grew very quick. Need to integrate dissimilar network devices, different vendors. Creation of single universally adopted architecture. You have a two like OSI reference model and TCP/IP. So it's an open system interconnection, OSI. Basis for connecting open system. This is distributed application processing. Open means connect any two systems conforming to reference model related standards, vendor independent. Doesn't matter you are Unix, you are Windows, you are Mac or any other Huawei or whatever like Android or iOS. With this OSI model, you can send to each other using the same protocols. Vendor independent, doesn't matter who's the vendor. Similar functions collected together. You have 7 layers of OSI. So layer 1, the physical layer, basically it's a cable. Mechanical, electrical, functional, it's like voltage, current, force, Newton, or capacitance or others physically, more to engineering side. Layer 2, the data link layer, control physical communication path before data send. Okay, transmission error checking. It's a frame layer. It's a frame layer on the MAC address, on the machine address. Okay, machine address is different from the IP address. Transmission error checking, frame transmission, establish and control physical communication before before data is sent. Okay. Hi, this one is HD link. Can't remember. HD is it's not the high definition. This one is a link control. Problem resolution is like error checking and error correcting. So this is done on the data link layer. The network layer, mostly the IP address. Address and routing services and which route it will use is the router. This is the switch, network switch. This is mostly a cable, wireless, etc. Network switch, and this is the router. Layer 3. Layer 4 also mostly a router. If you are a network engineer, you will use layer 3 and layer 4. Transport layer maintained by data between users. You have a TCP. TCP needs acknowledgement, and also you have a UDP, user datagram protocol, which connectionless. You don't have to give acknowledgement. The sender will not know whether the packet received or not. You have UDP and you have a TCP. The session layer. So like you are software guys, session layer and above. The session presentation application. AI, software engineering parts is all in the 5, 6, and 7 application, presentation, and session layer. More on the layer 7 and layer 6. Application layer, software side. How do you present to the end user? And you have a TCP IP model, transport control protocol, and internet protocol model. The oldest transport protocol standard, older than OSI. Internet communications basic, okay, TCP IP. File transfer protocol, send large files, error for free, okay, FTP, file transfer protocol, the simplest protocol for file transfer between one machine to other machine. So TCP IP emphasize inter-networking and provide connectionless services, okay. Connection services meaning that it doesn't have to have it doesn't need a feedback, connectionless. It doesn't predetermine the route and stuff. Also organize a communication system. So they have a 3 component: processors, hosts, and networks. It is 4 layers. So TCP IP model, process application layer is same with the 7 and 6 OSI model. Session layer and transport layer is host layer. Internet layer is a network layer. Okay, this for the network engineer. And layer 1 network access layer is data link and physical layer. So network access layer provides access to communication networks, flow control, error control between host, security, and priority information performed. Internet layer is equivalent to OSI model network layer performing routing functions implemented within gateways and host. So example is the internet protocol, okay, all the IP address and stuff. Host layer transfer data between 2 processors, different host computers. It done the error checking, like in the frame layer, flow control, manipulate connection, control signals. Example is a transfer control protocol. And you have a process application layer. Protocol for computer to computer resource sharing and terminal to computer remote access. And you have a FTP, SMTP, and Telnet. You want to transfer a file, you have your FTP. Simple management transport protocol, SMTP, and Telnet if you want to remote to other hosts. So this is a summary. You learn about memory, basic organization, terminology, ring topology, bus, and others, network topology and types, software design issues, and transport protocol standards. So we finish our so thank you very much, everyone. Have a good day. I think next will be a revision class will be handled by Puan Fazida. All right, I will upload this lecture into the Spectrum. Okay, yes?
Sorry to disturb you. I have one question regarding our final exam.
Yes, yes.
Because we are having the final exam on 26/6, right?
Okay, yes.
So, for the day 26/6, for the AI student that taking computer math, we also be having the final exam on the same date. So, is it possible?
Okay, wait. Only AI student have these problems?
Yeah.
Since okay, of course, this is online exam. Still, you can change. I will discuss with Puan Fazida because the advantage of online exam is determined by the lecturers. If physical exams, is determined by the exam sections. You cannot change the date. Okay, I will discuss. Any other departments have the same issues or only AI? How many do you think involved? I mean, how many students from AI had haven't checked the statistic yet? How many students from AI for this course? Never mind. I will never mind. I will check from the list of the name and your metric numbers. Yeah. Oh, okay. Some student need go to vaccination. Okay. Expect that. 20. Okay. Friday, 25 June. Okay. Okay. What you need to do is discuss among yourself. Give me one date, and at the same time I will discuss with Puan Fazida. It is okay for us to change, no problem for us to change, but you must give us one date. The date that where there is no clashes between other subjects and no vaccination or whatsoever. All right. We consider vaccination is very important. So anyone that have vaccination, we have to change the date, or we have to set another set of questions. Okay. Is that okay? Yes.
Doctor, it is mentioned that the online quiz 2 is cancelled. So, is it totally cancelled or will it be replaced?
It will be cancelled. It will be cancelled. If anything, I will inform in the Spectrum. Dr. Fazida told me. Puan Fazida told me it already being cancelled. Next will be a revision, I guess. Okay.
Okay, thank you, doctor.
Okay.
I'm sorry doktor, never mind that. Tak perasan yang CM dah tukar ke 25 Jun. So there is no
25 June. Okay.
yes.
Anyone have a vaccination date on that time? Okay. Anyone that have problems, just you can personally email me or message me through Spectrum. If nothing, if I have, if no one objects to this one, I will assume it will go on 25 June. Okay. I think because someone has told Puan Fazida and Puan Fazida changed the date. Okay. Anything else? If nothing, I will end this session, and hopefully you are okay with the total lockdown and stay at home, and okay, keep yourself together. We'll stay at home and fight this COVID-19. Thank you very much. Bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, doctor.
Thank you, Doctor.